Yes, class. So in the last class on Monday, we had completed till equipotential surfaces, right? Equipotential surfaces was over. So what is meant by equipotential surfaces? Equipotential surfaces are basically those surfaces where potential remains same throughout and work done is zero. And work done is zero. This is conclusion for you all. So this is what we did, and certain properties we had seen where one of them was that work done is zero, potential constant, it is perpendicular to electric field. If non-uniform electric field is there, is uniform electric field is there, how will you manage, right? Now, the last topic that is from your potential topic is electric potential energy. So see, obviously, if two charges are present, they are exerting force on each other. So always remember, whenever in your system two particles are exerting force on each other, they are able to interact among themselves, then definitely you will have potential energy. Likewise, two masses are present in class 11th. You all are just coming from class 11th. Two masses are present, right? So if two masses are present, they do exert force on each other, which is the gravitational force, right? So we do get gravitational potential energy. Why are we getting, what is the cause of potential energy in general? I'm not talking about this chapter specifically. In general, whenever we are talking about electric potential energy or any type of potential energy, in potential energy, you mainly have two quantities which are interacting among themselves. They exert force on each other. That is what is meant by electric potential energy. So the basic cause of electric potential energy, this is electrostatic interaction. If two masses are kept, they'll have gravitational potential energy. If two charges are kept, they will have electric potential energy, right? If charges are moving, they'll have kinetic energy, they'll have velocity, it will have its own acceleration and all. But we are not concerned about the motion right now. That's why we are not focusing on kinetic energy. But when forces come in your system, you do have the concept of potential energy. So potential energy is there in your system. Now, whenever you have potential energy, this is all just to how to identify whether which type of energy is present in your system, right? Electric potential energy is present in your system. If two charges are present, then only they'll have electric potential energy. This is just the first part. Second part of this is that this is basically the work done. By whatever calculations you are getting your answer, just calculate work done. Whatever work done gets stored in the form of potential energy. Fine, work done always gets stored in the form of potential energy. So electric potential energy is basically the work done. That is what I have written also here, that electric potential energy is the work done by external force in carrying charges from infinity to their respective position. If this is the case, that some charges are present at infinity and you are bringing those charges to some particular point, then when you're bringing those charges to that particular point, what will happen? Some work will be done, force is exerted, displacement is occurred, F dot, some sort of force will occur. So if force is occurring in your system, work is being done, then that entire work done gets stored in the form of potential energy. For example, we'll start with if we have system of two charges. Though we already know that we just do not have two charges, more than a single charge is always present. But if we have a system of two charges, right? So suppose I just have initially, there isn't any charge. Let's say there isn't any charge. There isn't Q1. There's just Q1. Fine, I have brought Q1 from infinity to this particular point A. Just Q1 is present. So if nothing is present around Q1, on whom will Q1 exert its force? Or just tell me one thing, but just answer me a yes or a no. When Q1 is brought from infinity to this particular point A, do you think that potential energy will exist in the system? Or forget about potential energy, just answer me a yes or no. Will there be a work done or not? There won't be any work done according to Austin. So who all agree with him? Who all disagree? There won't be any work done.
Ma'am, can I repeat this question?
Question is, if I have just taken one charge Q1, from infinity, I am bringing this charge to a point. No other charge is present, just Q1 is present. Will there be any work done in the system? There will be work done. Okay, both of you give me your reasons. Why, Austin? Why do you think no work done will be there? There will be work done, says Shahid. All right. I'm asking, Austin gave his answer. Austin, unmute yourself, Austin.
Yes, because there will be no other charge to exert a force on.
There won't be any other charge to exert. And what is your reason, Madiha? According
Ma'am,
to
because it's brought from infinity, so like there might be some work done.
no, see, and Shahid says that because force will be used to displace charge Q. Force is 0. From infinity, if you are bringing at that particular point infinity, which force is it? Austin is right, class. See, if no charge is present, what did we study above this part? We were continuously studying this part. Know that if a charge is present, more than a single charge, if two charges are present, there has to be interaction for the presence of potential energy in your system. For kinetic energy, I told you motion, movement and all you have to see. But potential energy, see in your lower classes you study, no, potential energy is caused because of change in configuration, size and all this one simple definition. But that doesn't help in your higher classes. You have to understand if two systems, two particles are present. I'm not even talking about charges. Even if two masses are present, basic simple two masses are present. I'm taking this pen, suppose I'll take one more pen. They'll also exert force on each other. They'll also have potential energy, right? So Austin is right. If charge 1 is brought from infinity to this particular point A, there isn't any other charge to exert force on. There isn't any force, right? So work done in carrying Q1 from infinity to A, work done first will be that. Now I am modifying the question. Now I am bringing one more charge, Q2 from infinity to this particular point B. And separation, relative separation between Q1 and Q2, I have taken it as R12. Just to generalize it, that this is a separation between 1 and 2. R34 if I write, so that if you just even read R34, you will understand, no, there's the separation between 3 and 4, third charge and fourth charge. That's why the relative separation I'm writing it as R12, means the separation between the first charge and second charge, fine? Now see, now in your system, Q2 and Q1, both charges are present. Q1 will be having, see when Q1 was only present, Q1 was not having work done, but Q1 was having its own field, electric field, potential energy, potential, electric potential was present. So due to this potential also, you will be having potential energy in your system, one thing. Secondly, when you are calculating work done on Q2, you can easily use this formula, V is equal to work done divided by charge. This formula is helpful for us now, right? See, when we are talking about charge Q2, work done in carrying Q2 from infinity to this point B. Look here, work done in carrying infinity to B, it's Q2 multiplied by change in potential. That is final potential, B point, minus initial potential from where I have brought the charge, that is infinity. So Q2 BB minus V infinity, right? Now see, always remember, at infinity, if your force is 0, at infinity, your potential will also be 0. There isn't any potential because infinite is not, you cannot define it, right? So V infinite also becomes 0. So what is the value of VB? See, for a single point charge, can anyone tell me if Q2 charge is present on this Q2? Just have a look. All of you at least should try this. Q2 is present because of the potential exerted by Q1, there we are having work done. I'm not asking you the work done. My simple question to you is, if Q2, we are calculating the potential that is being exerted by Q1 on Q2, what will be the value of potential? Yes, class, what will be the value of potential? See, this is the charge that is exerting. So will Q1 come or Q2 should come in the formula? General formula is KQ by R. This also I have told you. General formula is KQ by R. Now what will be K? K is constant, that is also fixed. So one thing is for sure, this is K. Which charge, which R? Yes, class? Yes, Shahid, try. See, you are calculating on Q2, but because of Q1, Q1 is generating the potential. So your charge will be Q1 only. Q1 is generating the potential. No, we are calculating the work done due to charge Q1. So this is Q1. And what is the separation between Q1 and Q2? R12. This is the potential which is required. Now, once you have the potential, work done. This is charge multiplied by K Q1 by R12. What is the formula of work done? That is W2. What is the formula of W2? This is K Q1 Q2 divided by R1. All right. So this is work done. Are we studying work done right now? We are calculating potential energy. So what will be the total work done? First, let's forget about potential energy. Total work done will be W1 plus W2. W1 was 0 because no other charge was present when Q1 only came. When the second charge comes, this becomes K Q1 Q2 divided by R12, which is simply K Q1 Q2 divided by R12. This work done, total work done of your system, this entire work done gets stored in the form of potential energy. So if it was K Q1 Q2, so this entire gets stored in the form of potential energy. So your potential energy for the system, this will be work done with exactly the entire work done, K Q1 Q2 by R. So what is the general formula of potential energy? K Q1 Q2 divided by R. I am repeating, formula for force, electric force using Coulomb's law, K Q1 Q2 by R square, right? K Q1 Q2 by R square. Formula of electric field, KQ square, KQ by R square, right? Then formula of potential, KQ by R. Formula of potential energy, K Q1 Q2 divided by. These are all the generalized formulas which you need to understand. Fine. Now, if n number of point charges are present in your system, that I'll tell you. First, note it till here. This is actually the formula which you will be using most of. Note it from here. Make the heading electric potential energy and start. See if n number of point charges are present. This was when we had two charges. So if you have two charges, this is the generalized formula that you have to use, and that formula only will be valid, right? And if suppose you have more than a single charge present, so now directly using superposition principle will not help. So suppose if I bring charge 1, for charge 1, first charge, it will be 0 only, not infinite, it will be 0 only, because there wasn't any charge when it came, right? This was 0. Work done 2 also we have figured it out already, that it will be Q1 Q2 divided by R12. Relative separation between these R12, R13, or nth, whatever that you can take. Fine, whatever amount of charge. And if you're taking between 1 and 3, that will become 1, R13. So it's just to name the separation between the charges. If I say R4, 5, so that means separation between 4th and 5th charge. Right, it's just to understand right now for the derivation purpose. Once we start with the question, no, you will yourself see that this 1, 2 doesn't matter. You just have to understand the basic generalized formula. Now, suppose I'm carrying the charge Q3 to see. Only just look at this 3, 4, 5, 6, 7th infinite, I'll tell you by just a single trick. But till 3, let's see how difference arises. So for example, charge 3 is there. So work done in carrying Q3 from infinite. So this will become work done in infinity to C, Q3 multiplied by VC minus V infinite. Right? This is Q3 multiplied by VC minus V infinite. Now, see, VC and V infinite we have to find out. So V infinite in any case it would be 0. Fine. Work done in from infinity. Yes, this is again all the charges are present in infinity only. All the charges, these are present in infinite. They are infinity only. Fine. Yes, so when we are talking about VC, see, because of VC, there will be presence of two charges, right? Because before your Q3 was present, Q1 and Q2, both the charges were present, right? So because of Q1 also you will be having a potential, and because of Q2 also you are having a potential. So this is Q3, V infinite is 0. Just a second. Class. When charge work done is between infinity to C, so VC is because of two charges now. Q1 and Q2, two charges are already present, right? When we brought Q2, only Q1 was present, so we had two charges. When we brought Q1, no charge was present, so work done was 0. So V infinite is still 0, but VC will be K Q1 R13. Look here. If I'm talking, just look here. This is first charge. This is Q3. Their separation is R13. What will be the potential due to Q1 on Q3? K Q1 divided by R13, right? If suppose I'm calculating this, the same thing for Q2 on this Q3, R23. The separation between charge Q2 and Q3 is R23, not R13, R Q23. So that will be K Q2 divided by R23. Any charge you take, charge by because of the charge which the potential is being produced, that charge we mention. Fine, that charge we mention. And whatever is the relative separation between the charge of calculation and the charge that you're taking because of which potential is being generated, that separation is taken in the denominator. So here this becomes K Q1 divided by R13, separation between these, then a separation between Q2 and Q3. This becomes Q2 and Q3 is R23. So V becomes, this is plus K Q2 divided by R23. Fine. This is just VC. Fine. VC means potential on point C. That will be due to charge Q1, that will be charge Q2. Separation between Q1 and Q3 was R13, so we took it as R13. Separation between Q2 and Q3 was R23, so we took it as it is. Now see, just multiply it within the brackets. So this work done becomes K Q1 Q3 divided by R13 plus K Q2 Q3 divided by R23. So now see, similarly, if I bring one more charge, now just understand this by technique. This is by derivation. I hope you all have understood. Just give me a second. See, when you have charge Q4 coming, now do not perform the entire derivation. Otherwise, this will take so much of time. You will first write W1, then you will write W2, then you will write this part. This is W3. Then you will write the individual portion of W4. Right? If we actually go by this, so just remember one technique. If Q4 is present, right? If Q4 is present, what are all the charges that were present prior to Q4? Q1, Q2, Q3, they were already present. What is the relative separation between them? R14. Relative separation between them R24. Relative separation between them R34. Right, this is how we name it. What will be the potentials value? General formula is electric potential energy K Q1 Q2 divided by R. So K, first let's talk about this. Q1 is Q1. Q1 is Q1 and second charge is Q4 divided by what is the separation between them? R1 plus. Take this second one. This becomes K Q2 Q4 divided by R24. Third one, K Q3 Q4 divided by R34. You have obtained W4. W5, if you are getting it for the fifth one, what will you do? Again, you will put it this as Q5. Then you will write down the charges that were present prior to Q5 and then you'll write. But see, if the charges are given in a lot of number where it is difficult for you to put, just make it a simple trick is that to write this. Simple trick just to write is that for nth, this becomes Q1 Qn divided by R1n plus whatever is the charge that you have taken. Then second charge will come with that nth one, let's say 5, 6, 7, whichever n you are taking. That becomes Q2n, R2n plus up till. So best method is just write this as Qn minus 1, Qn divided by Rn minus 1. Means 1 just lesser than that we are writing, no, multiplied by n. Right, this is what we are writing. At the last, when you add all this is just to understand in detail. We'll just write the reformed form of it. So that will become easier. So basically, what is the net work done you are having? 0, which is work done first. K Q1 Q2 divided by R12, second work done, plus K Q1 Q3 by R13 plus K Q2 Q3 by R23. This is work done 3. So like this, nth you will have as KQn minus 1. This is Qn divided by Rn minus 1 multiplied by n also, because 2n, 1n we write it like this. Understood? So see class, how to come directly to it. Otherwise, you have to perform all the steps. You have to perform all the steps in your derivation. But in general, how will you understand? When the first work done came, this is W1, no charge was present, directly 0. Then second came, second work done. 2 charges present, put it in the formula K Q1 Q2 by R. So 2 charges present, K Q1 Q2 divided by R12, their separation. When we are talking about Q3, So if Q3 is present, 1 will be because of Q1. So K Q1 Q3 by R13, and second will be because of Q2. So K Q2 Q3 by R2. Then suppose here only I had fourth charge. So I won't solve it now. Fourth charge is there, it means K Q1 Q4 by R14, K Q2 Q4 by R24, K Q3 by Q4 by R34, like this. So three energies I'll have, the three amount of interactions, because three are able to interact among themselves, right? Now this entire answer which I have got, this is exact value, just keep on writing it as it is exact value of potential energy. So I can write the generalized formula, that is just to understand in very much detail. If you have 1 charge, 2 charge, 3 charge, suppose you have 5 charges and you are calculating the energy on the middle charge. So one energy will be because of this corner charge, one energy will be because of this corner charge, then this corner charge, then this corner charge, and this corner charge. It is also possible that inter energies between these can also be written. So what you have to find out, you first have to figure it out, where exactly is the number of interactions. I think this is just a way to write it. Mainly you learn this K Q1 Q2 divided by R. This will only help you. See, throughout we have been using 5, suppose 6 charges are present. So K Q1 Q6, K Q2 Q6, K Q3 Q6, like this. This is just one gist of entire thing. Let us practice questions, then this part will become more clear. But if it comes in your exam to derive, then from here for nth point, just see which question is it. Sometimes, so most of the time for 2-point charges are given. So that time you use this, what you have written. But just in case, if it comes for n-point charges, directly write it till here. That is sufficient for your 5 marks. If it will come in your 5-mark questions. All right, note it down. And some of you in your answer sheets, when you are performing a derivation, most of you have performed a derivation part, no, electric field due to infinitely long wire was there in your question, correctly. But see, when you are deriving, you have to mention the variables. You cannot just directly, I think Shahid or Chavez, I don't remember, someone did this, entire derivation was correct, written in this small portion, but nothing was explained. What is lambda? You know lambda is linear charge density. You have to specify, in the board exam, that assuming lambda is linear charge density, right? Assuming, or where E is equal to this, any new variable is written. We even in our class derivation also, at the corner I mentioned what is the meaning of the derivative. So when you're writing in your exam, you have to write it properly, more properly than what I write in the derivation of the class. You have to mention this, that let us assume that this is this, and you have to keep on explaining why are you taking 90 degree there? Why is your electric field coming 0? So you have to specify, you have to mention in the bracket, at least mention theta is 0 for the circular part. Like this, you all have to specify. This was a very common mistake which all of you did. And the calculations, first question, nobody has done it correctly. Nobody, not a single child has done. Those who have lost marks, I think Austin and Madiha have obtained the highest. They have scored the same. So they also have losing their marks in the first question. The rest of the entire paper is correct. I think you've got 23 out of 25. So 2 marks were lost in the first question only. When you're having a triangle, all of you could come to this conclusion that all the forces were equal, right? When all the forces are equal, so when you take that under root for the net vector, that becomes f square plus f square plus f square. So that is root 3f. So root 3f is the answer. Most of you have left it at that step. Actually, most of you have not even attempted it well, but some of you have left it at that step. So one more step was required for the final answer. Otherwise, properties of electric field, you all have written good. Tarif, you need to improve on your theory part as well. Electric field lines question, I think, was the easiest among all the questions. 5 marks for just writing 5 to 6 points. So whatever field lines you have written, no, and try to just make the figures also. Most of the properties when we study in the class, we are continuously drawing the figures also. So figures also, see, these questions you were able to do. The 5 markers derivation and the theory part you all were able to do. Torque question also, everyone gave the correct answer for torque. And that also, that 120 units was also coming for one question. A flux, I think. That also you people were able to do. But seventh question also, some of you have not attempted. I think Shahid has left that question also. So whichever, at least just try it. Because in that, all the parts weren't difficult. Third part was the easiest. In the second part, you were just getting directly 0. Right. So just at least try to attempt all the questions. It can happen that you will get half marks for writing the formula, 1 marks even, just in case. So do not avoid, if you just directly write no, don't know, or I do not remember the answer like this, then what will happen? Directly 0 will be given for that question. Even if you attempt, like for the first question, all of you have at least attempted it, though it is incorrect or it is incomplete, but at least you people are scoring 1 mark for writing the formula, for reaching till even this step also. If you are reaching all the forces are equal, you are getting some marks. If you leave that question, all of your marks will be lost. So just take care of all these things. Otherwise, all of you have done well. Let's see for the next test now. All right, note down this part. Diagnostic test, you people have not scored well in the last diagnostic test. I think only Madiha has scored good, 4 on 5. Most of you have scored 1 on 5. I have to check the scores. I'll discuss it if you're having doubts, any doubts from that diagnostic test. All right, note down this part.
Sorry, can you scroll up?
Yes, U is potential energy and W is work done. So they are actually different, but work done gets converted into potential energy. That's why I'm equating both of them as same. K gets multiplied. K Q1 Q2 divided by R. It is getting multiplied. Eighteen is right. 10 to the power 9. I think 9 won't be there. It would be 3. 10 to the power 3 should come. The answer. See, one charge is given as 2 millicoulombs and second charge is given as -3 microcoulombs. And the separation between both the charges is 3 millimeters. So for calculation of potential energy, formula is very direct. K Q1 Q2 divided by R. But the problem is that we have to convert every term into its standard SI unit, right? So U is equal to K Q1 Q2 divided by R. So first charge, this is 2 millicoulombs. So that becomes 2 into 10 to the power -3 coulombs. Second charge is -3 microcoulomb. So that becomes -3 into 10 to the power -6 coulomb. And separation is 3 millimeters. So that becomes 3 into 10 to the power -3 meters. Fine. So U is equal to K is 9 into 10 to the power 9. Q1 is 2 into 10 to the power -3. And Q2 is -3 into 10 to the power -6. Now separation between them is 3 into 10 to the power -3. So 3 gets cancelled. This 10 to the power -3, this gets cancelled. So see, 9 into 2 is 18 minus sign. And 9 minus 6 is 3. So 10 to the power 3 joules. This is the answer for potential energy. Second part, what it is saying? Work done to make the system. See, potential energies are basically of two types. Your potential energy's final value is -18 into 10 to the power plus 3 joules. Work done to make the system. This is the potential energy only, because it was the work done only, no, that got stored in the form of potential energy. So this will be -18 into 10 to the power 3 joules only. Fine. Now come to the third part. Third part is important and it is different. Decide whether the system is bounded or unbounded. Always remember, potential energy, when this is present, your potential energy is of two types. It can be positive, it can be negative. If your final answer is coming as positive, means your system is unbounded. If your system is coming negative, it means this system is bounded. Always remember in this theory part of it, though it's usually a part of class 11, but the application can come till here. So third part, our answer is coming negative. So if our answer is coming negative, means system is bounded. So system is bounded. Fine. Fourth part comes work done. But the formula of V is equal to KQ by R. Why did we use KQ1, Q2 in question? That is potential. KQ by R is potential. Question wasn't saying potential. Question is saying potential energy. Whose formula is this? Clear? Was asking Shahid. Clear, Shahid? Potential and potential energies have difference. So work done to make the system. The fourth part is saying if bounded, then calculate work done to break the system. Always remember, work done to make the system is negative of work done to break the system. So work done to break the system, this will be negative of this, that will make it positive, 18 into 10 to the power 3 joules. This is the answer to the first question. Note it down. See, negative because that shows the attractive nature when we have negative. So if everything is getting attracted to a particular point, it means everything is bounded. When it is positive, means there is no attraction force. Repulsion forces are present. So your system scatters. That's why unbounded. All those who have completed, please just text me done in the chat column. Okay, Rabi, you can note it from here. See, in the last diagnostic test which you had, see, first question was very easy. What is the formula of electric field for given potential? E is equal to minus dV over dr, B option. And assertion reasoning also, electric field is equal to negative rate of electric potential. So this means this is true. And secondly, it says that electric potential is a scalar quantity. That is incorrect. And gradient gives electric, right? So see, this means first part is right. Electric field is equal to negative of the potential. So that is also, I think you will be able to do. The calculative questions which came and the analytical questions, these types of questions also we have done. 6x square minus 3y square plus 2z square. So once you are differentiating this for x-axis, you have to keep y and z constant. You have to keep y and z constant, right? Then you have to put in the values at the last as 1, 2, 3. Then analytical also you have to partially differentiate. In the advanced, the question came, the electric field in the region is given by this term. The values of constants were given to you. If the potential at x is 1, right, and that x is minus 5 is V2, what is V1 minus V2? See, here also in this question, what you have to do, you have to write down E as ax plus b. Then you have to find out values of constant. You have to find out the value of potential. So E is equal to minus dV over dr, right? So dV will be equal to E dr integration. This is what you have. All right, if you have any particular doubts from the last test, please let me know. Otherwise,
Can you just repeat what you said?
see, when you have E is equal to minus dV over dr and you want to find out what is V, then simply integrate E dot dr, integrate it, you will get potential back. These are reverse operations, fine, they are just reverse operations. So let me see your score. So Tarif, Humam, Austin and Shahid have 1. Rabia and Faiza have 2. And only